I want to make a quick announcement to the room and tell you that while the agenda ends at about 6:30 today, it's not over. Okay, there will be a reception at 6:30 p.m. at the library 4th floor patio area. So who's been to the library 4th floor room already? All right, and if you remember, there's a patio off the side. There's going to be a reception up there at 6:30 tonight. So I just want to let everyone know that's the situation. And with that, it looks like the room's pretty full, so it's a little early, but if Jesse's ready, this is Jesse Anderson, the CEO of Smoking Hand. Very cool. Thank you, Jesse.
Thank you. Thank you. I'll just give a second just in case people are coming in, but thank you again. So one of the things that we'll be watching is I put some Legos right here in front of this gentleman. Who thinks that he can go the entire time without touching them? Nobody? Okay. Your name?
My name is Vikas.
Vikas. Okay. And your name? Les. So Vikas and Les made the mistake of sitting here in the very front, and they don't know that they're actually unwitting participants in this in our little talk today. So Vikas and Les, this is the shampoo line where you get wet. All right, good. So why don't we get started? I'm sorry, got a little bit more time. So I guess I'll get some info about you. How many of you are professional developers? Good majority of you. And have you Java developers? And how many of you are Python? A few of you? Okay, and how many of you are students? A few of you? Okay, good. How many of you are interested in Kafka? I see some hands not up.
Just lazy.
Lazy? Laziness is not an excuse except here for eventually consistent data. Nobody? Nobody's a NoSQL database engineer. Okay, let's see, what other jokes do I have while we're waiting? So the rest of you who didn't raise your hand, just shout out your business intelligence analyst, something like that. Yes? Okay. And you don't want to say? You work for the government? Okay, so now we are at that time. Let's go ahead and start. So once again, I'd like to welcome you to this session. As you saw by the show of hands, this is a session about Kafka. If you're not interested in Kafka, there are far more interesting places to be right now. That said, we're going to talk a little bit about Kafka. So to start off with, what is Kafka? Kafka is what I like to describe as a distributed publish-subscribe system. So how many of you are familiar with the publish-subscribe system? Good majority of you. Okay, so generally pub-sub systems are non-distributed. They're usually from a point to a point. But wouldn't it be interesting if we could do some other things where we could start distributing that loadout and hit some really, really large numbers of messages per minute or per day? So right now the high watermark for number of messages per day is 1.4 trillion. That's T with a tree. That's the Quattro Commas Club. So here with the Quattro Commas Club, we have Kafka, and we have LinkedIn doing that. So Kafka was originally created at LinkedIn and open source. They were very kind to do that. They open sourced it in 2011, and they became what's called a top-level project in Apache in 2012. And as a result of this, we have some pretty interesting things. So if you keep up with your big data and you've read your big data papers, you know that very often a big data project is actually the result of a paper. Somebody read the Google Big Table paper. Somebody read the Google MapReduce paper. And then they said, I'm going to make this open source implementation. With Kafka, on the other hand, LinkedIn actually took the code that was running in production and said, here you go, world. Here's the actual source code that we're running. As a result of that, we don't have something that's a clone. We have something, this is what LinkedIn uses and continues to use. So generally, if you're not familiar with what a pub sub is, or what's called a pub sub, you're going to need to understand it a little bit. So you might have heard it as called a pub sub or a consumer subscribe system. There are various ways of thinking about that. In a very, very basic sense, The publisher gives data, creates data. The consumer consumes that data, reads that data in, and it processes that in some fashion. So then we have this thing that's very, very important in systems, especially in big data systems, is that we need to decouple. Decoupling means that if we have two systems, how much knowledge does one system have about another system? The more knowledge that they have about each other, the more fragile a system is. Fragility in this case means several different things. It'll mean that it's going to be tearing out our eyes in order to make an update. It's going to mean that when something goes down, everything fails catastrophically. How many of you have ever experienced this? A few of you, yes. You curl up at night thinking about these catastrophic, highly coupled failures. It's not fun. So you know why I teach now instead of code? It's for those reasons. I don't get calls at 3 o'clock in the morning. You guys do. So when we have these highly, highly coupled systems, we have this extreme knowledge known about these two sides. What we want to do is decouple so that a minimum amount of knowledge is shared between the two sides. So why would you go about using Kafka with big data? Well, it's already proven. If as you heard, the Quattro Commas Club, that 1.4 trillion, that's a significant number of messages per day. So I'll speak at other conferences and they'll come up and say, hey Jesse, I work for large company X and we get 100 billion events per day. Can Kafka handle that? And say, yeah. And I'm nonchalant about it because that's really on the low end of what I deal with when I teach at companies. It's because you're not hitting that high watermark. Just so you don't think that LinkedIn is the only one using it at large scale, Microsoft publicly disclosed that they are at the Quattro Commas Club too, where they're at 1 trillion messages per day for some of their clusters. So as a result of running at LinkedIn, it actually answers several questions for us. It answers the question, does it scale? Yes. Is it fast? Yes. Is it robust? Yes. Is it production ready? How many of you have had downtime on your LinkedIn? So, a few of you? So, pretty few and far between, but it does happen. There is extensive usage of LinkedIn that's going to allow us to see the answer to these questions. We're seeing that LinkedIn uses it and has good success with it. So, as we think about what Kafka is, it supports these traditional pub/sub things, but it also does quite a bit more. Quite a bit more interesting things that are aimed at specifically at big data. So, back to the Shamu row here that encompasses two guys. Maybe we'll bring in this guy who thought he was out of clarity. You see the look on his face? Jesse. It's always good to meet a fellow Jesse. We're great people. Okay, so what we're going to do is we're going to demonstrate with Legos some concepts behind Kafka. And this is actually important. This will help you understand how Kafka works vastly faster than showing a bunch of diagrams. So what I'm going to do is I'm going to have Vikas hand me a pink Lego. So this should be, hopefully everybody can see this. This pink Lego means data. This is, and so Vikas here is going to be acting as a producer. He's going to be giving data to me. I'm going to be acting as the Kafka cluster, and Les is going to be acting as a consumer. So what happened was Vikas, as the producer, handed me some data. I'm the Kafka cluster. I'm going to take a copy of this data for myself, and then I'm going to walk over to Les and say, take the data from my hand. There was a reason why he took the data from my hand, and I didn't just give that to him. Okay? So hand me another piece of data. Thank you. So here, I take a copy of that data for myself. I say, Les, take this data. Okay? And already with the data, good job, thank you. This is gonna, we're gonna do that in a different way. Okay? And now hand me a few pieces at once. Hand me these three. Okay? All at once. Alright, so Vikas has handed me several pieces of data, all coming in concurrently. So one of the things that's important is we need a system that can handle a lot of different producers. So let's say several different machines all handed me data at once. what we can actually do is the Kafka cluster is we can create an order out of this. And this is very important so that consumers like Les has a very consistent view of data. So what we're going to do here is we're going to take this data and we're going to order it. And so here I've taken a copy of this data for myself, and then I come over to Les and I say, here is your data in this order. Let's go ahead and take it. Or you take it. You've got to maintain this paradigm. Okay. All right, good. So here, I have this thing in my hand. Okay. So what was the knowledge? Anybody throw out, what do you think the knowledge that Vikas and Les maintained between themselves? There were two things in particular.
The order?
I'm keeping the data, but that's not what the knowledge that the two of you need.
The order of the data?
The order.
No, not order. Color, not quite, kind of. So kind of what he said, color. There has to be an agreement between the two of them about what the data looks like. So they need an agreement about data structure. This is something I won't have time to talk about, but it's actually pretty important that you be able to understand each other. And then there's the other thing that they needed to know about, which we haven't talked about, is a topic. So Vikas needs to talk on a topic, Les needs to consume on a topic, okay? We have this other thing called partitioning. So if you saw and you watched closely, I told Vikas not to hand me the monochromatic blocks, the gray and black blocks in this case. That's because we're going to imagine that we're going to have chromatic blocks in one partition and non-chromatic blocks in another partition. So go ahead and hand me some blocks. I'll just take a couple. Okay, so here we have a black and gray block. And I take some copies of those for myself. And then over here with Les gets those blocks too. All right, good. Okay, so there was a reason why I had them in two different places. That's because we're doing what's called partitioning. This is one of the ways that we scale Kafka. Instead of all the data going into the same place each time, it's actually partitioned out into several different things. So sometimes this partition will manifest as being a completely separate computer altogether. So instead of there being one computer handling, or one node handling all this data, there's actually going to be lots and lots of different machines all handling this data. We do this by breaking the data up into partitions, okay? So physically, this manifests as two separate things, two separate partitions, and on disk, even if they're on the same node, they're actually physically different directories that are right there, okay? Then we have an obvious question that will come up of, okay, well, we're saving all this to disk, so every single one of these messages is saved there on disk. Disk is a finite amount of space. We can't store forever. What we have to do is do some level of log compaction. We have to delete some data. So there's two ways of doing that in Kafka. We have a way where we just say, lop it off, and we've freed up some space. There's another way called, or a tension policy, called a compaction, where instead of just lopping it off, we might want to keep the last version of everything. So let's imagine that each one of these colors was a key. So what we could do is, this older green one that's right here, we may not need that. We may not need this older pink one. What we may want is just these. So by the act of actually only including the latest versions of each one of these colors, we can actually save some data there and save some space. So those are two different types of compaction policies. So there's one thing. So Jesse over here thinking this entire time he's out of the woods. So what's interesting about Jesse is he was hit by a bus. That entire time Vikas was over here sending out data, he was there in the ICU in a coma. So did he miss out on that data? The answer is no. What he'll actually be able to do is when he comes back out of his coma, he'll be able to contact me as the Kafka cluster, and he's saying, I've been out of a coma for 2 days. Can you give me the data from those last time I talked to you 2 days ago? And I'll say, here you go. Here's all your data. And Jesse doesn't miss out on data. So while it may be 2 days, while it may just be a bump of a minute or two, or whether it's a reboot for some downtime or an upgrade, there's some pretty interesting things that we can do with Kafka as a result of me storing that data. Okay? So let's talk a little bit about internals. Once again, our publisher in this case was Vicus. Thank you, Vicus. So Vicus was the one who was sending that data into me. All that data that he sent was in the form of keys and values. This is a very common paradigm with big data, where a lot of times it's a key and a value. So there was some level of information that was stored in that reason for using a particular key. And that was so that we could partition in this case. So these actual keys and values could be binary, it could be text, what have you. Consumers, in this case, or subscribers, in this case it was Les and Jesse, they were both consumers. And they received those keys and values as sent by Vicus. Topics, remember that was the shared data, there was some amount of shared knowledge. So Jesse and Les were listening on a topic that Vicus was sending his data into. So, API. So there was a reason why I asked you a little bit about your languages. We're obviously going to have to program this. And the Java is one of the best ways to go about using Kafka. There are other methods for using it. We have things like a REST API. By using that REST API, we can make RESTful calls. At the end of this talk, you'll see the URL to my YouTube page. I did a screencast of an example that I created an entire web page that just did AJAX calls over and over again, didn't use a servant, it just called AJAX directly into Kafka and consumed right there in real time from the web page. Go ahead and take a look at that. It's open source if you want to see it. We also have other languages. We have languages like Python, those sorts of things. They have native implementations. There's also a C and C++ implementation. Then we have Kafka Connect. That's going to allow us to bring data into Kafka in an easy fashion. Where would we be without code? Hopefully you in the back can see that. This is what code on Kafka looks like. So here on the Kafka, we have Borg Apache Appliance Producer, Kafka Producer. We need to do a few things there. We need to have our bootstrap servers. This is a non-exhaustive list of servers that we need to connect to initially. In this case, it's brokers. And we have to say, here is the way I'm laying that data out. That's that key and value serializer. In this case, we're saying, I'm going to send strings across the wire. And then we actually have create our Kafka producer. And from there, we create this producer record. This producer record is going to say, here is the actual data. So when Vicus was sending out that data, it would be a key of green, let's say, and a value of I love Kafka, something like that. And then here we have the actual topic. So that's that data that they needed to agree on. Vicus needed to say, here's the topic I'm sending out, and here's the type of data that I'm sending out to. Then we can send that out. On the consumer side, we have to do similar things. There's our imports. Then we have our properties. Properties, we have to create our broker and say, here's an initial list of brokers. We also have this thing called a consumer group. That's something I haven't specifically talked about. But one of the really, really cool things about Kafka is the ability to say, remember how Jesse went down because he was hit by a bus? Wouldn't it be great if we could clone Jesse several times so that if one clone was hit by a bus, the other ones would take over? So that's one of the really cool things about Kafka is that we could have n number of Jesses all working and running at the same time. And what will happen is, you remember those partitions that I showed? How there was the chromatic partition and the non-chromatic partition? Well, what the Jesses would do is they would divide up those partitions amongst each other. And so they could all run in parallel and not really step on each other's toes. And what's really cool, we can scale. You can keep on adding Jesses as you needed to. Or when one Jesse gets hit by a bus, the other Jesses are right there to go. So, did you know there are that many Jesses? There's at least 2 of us here. So here we are. We have to agree on the data, the way the data is being sent around. That's our key and value serializer. And then we create our Kafka Consumer, and we subscribe to a topic. That's that topic that Vicus was sending out his data on. Then we do our polling. For the sake of simplicity, this is not multi-threaded, though I do suggest you do multi-threading. Here, that while loop is just a true. It's just continuing and continuing to go through this data, getting the consumer record. You can see that there in the consumer.pull, pulling back the list of messages. In this case, the list of messages would be all the Legos. And we get a hold of those record keys and record values. And we have lots of data coming in. Very interesting pieces of data. Okay, so I believe we have a few minutes for questions, but before I start doing that, I'll throw out a few plugs for myself. So if you like this style of training, where we do things with Legos and we play with Legos, this is what I do for a living. I train at companies. I train at Fortune 100 companies, especially on Kafka. Before this, I was at Cloudera and senior software engineer even before that. I was telling this gentleman about other things I've done. You know how I had that monkey up there? That's because the monkey is my moniker. You may have heard about a project I did where I randomly recreated Shakespeare with Hadoop. That was about in 2011, so you can go on my site and read that. My site is jesse-anderson.com. As a result of that, I was covered in everything from Wall Street Journal. I'm published extensively, and I speak at Strata. So you can feel free to connect. So go to jesse-anderson.com. That's a place where you can do that. One thing I will throw out, because I haven't seen it talked about in this conference, those of you who are trying to become data engineers or people who work with big data and specialize in big data, this is something that's actually more difficult than coming to a conference at a single point. It's actually something that, in my opinion, you have to specialize in. I don't think enterprise developers can be generalists anymore. I think you have to specialize specifically in big data now. You actually have to know these nuances. So there are nuances that I didn't talk about with Kafka that the average person won't know that will really, really bite you. So it's in my opinion, it's incredibly important that enterprises start differentiating between their engineers and those dedicated to big data, which are called data engineers. So what I do is I teach data engineers and data engineering teams. So once again, there's my YouTube channel. You can go there. If you want to show your pointy-haired boss or your coworkers this really cool thing, I actually did this on my YouTube channel. You can watch it on my YouTube channel. I explain how MapReduce works with playing cards on my YouTube channel. So all sorts of different interesting things there. That's it. Let's have some questions. In the back.
Does Kafka implement the JMS API?
Question, does Kafka implement the JMS API? And the answer is no. It's its own API.
Can the producer restrict consumers from viewing their data? For example,
Yeah. So her question is, can the producers restrict data viewing, consumers viewing that data? The answer is no, that the producer is not the responsible one for that. You may be thinking about in terms of encryption, so you can do some level of encryption. Kafka also supports authentication and security, so you could, using configurations, be able to say, Jesse has to authorize in order to be able to consume on this. And that's something new as of the 09 version. Okay. I'm going to go to this side of the room.
Partitioning, does that happen on the subscriber side? Is it just reading a topic and filtering based on what it's agreed on with its neighbors, that it's going to actually process?
Sure. So the question is, how is partitioning done? There are a couple ways that partitioning is done. There's an automatic way that's done based on key. So in that example that we were showing up here, we said that the key was just arbitrarily chromatic and non-chromatic. You can also specifically at the producer say, Vicus could say, I want to produce into this partition, I want to produce into this partition. And there's another way where you don't use a key, and that uses what's called a round robin. So it would send to all the end brokers of me and try and use the resources as efficiently as possible. By doing that, you could, those sorts of use cases are more focused on log metrics and that sort of thing. The reason why you would use a partition or not is for ordering and so that a single consumer views all the data. That's the very basic nutshell of it. Since he helped out less. The question is, does Kafka support topics or queues? The answer is it only supports topics. So one thing I'll point out specifically is that if you're coming from a RabbitMQ background or perhaps a JMS, Kafka itself, so when I was acting as the cluster, I don't introspect into the packets at all. That means I just get bytes in, I save them, and I send bytes out. I don't look at what they are, I don't validate them. That's something that the producer and the consumer need to decide on. Okay? I'll go back to this side.
Anything that Kafka can do that Kinesis cannot do?
I don't know enough about Kinesis to answer your question. The major thing that I've seen with Kinesis is a 7-day limit. Other than that, I don't know. With Kafka, you obviously can save as much as you want. With Kinesis, they have a hard 7-day limit on data. Am I on time? 5 minutes?
Yeah, you're fine. Yeah.
8 minutes. Okay. There was a question that I kept on seeing over here.
It's not a good question. You want to ask, does Kafka handle synchronized requests?
Synchronous requests.
Yeah, requests and get requests.
So
Also, it's just a publish and on the other side, nothing.
yeah.
Only the storage was on the other side.
So generally, Kafka is set up a little bit different in terms of so if Vicus wanted a response back from the cluster, he could do that. Generally, it's not done. Generally, Vicus is, don't take this the wrong way, generally Vicus is very dumb at what he tries to do. His job is just to say, here's the data, and usually less is to just receive that data. Sometimes there's a conflux of the two, but they don't usually receive their own data. Sometimes what will happen is that less and Vicus are shoved together, and they'll be both a producer and a consumer. Well, they'll bring in some data, enrich it, process it, and send it back out. Back?
So you talked about millions of, trillions of records. So is this number across multiple clusters or a single cluster? If it's a single cluster, how big are these clusters in terms of number of CPUs, memory?
So a question about sizes and numbers of cluster. You can go to LinkedIn's blog and they talk about it, and Confluent's blog talks a little bit about it. But yeah, it's several different clusters, and what they're trying to do is it's more for DR purposes, for disaster recovery purposes, that they'll have multiple clusters moving data around. But do a search on that and you'll find the info.
Can you achieve a point-to-point connection?
Can you do a point-to-point connection?
Like instead of a topic, like a queue?
No. So the question once again is can you do point-to-point? The answer is no. You always flow through the Kafka cluster. There's no direct RPC from one to another. There are better frameworks, there are other better technologies for that sort of thing. Okay, looks like we've dried up the questions. Thank you again for coming.